Maybe they're just like replacement.
Yeah.
They have one car with there. They like a whole car. Right. And we're like,
Okay, hello everyone, hello. Thank you so much for having me, everyone. My name is Dakota Jones. I'm gonna kind of awkwardly be in between the two of you guys, so just see both screens and make sure everyone can hear me. Who has heard of Kingspan before we get going? Excellent, that's fantastic. Who's done work with insulated digital panels before? IMPs, excellent. And then would one of you mind sharing your experience with IMPs? Good experience, bad experience? Different? Okay. Well, as long as it's not negative, that's completely fine. But I'd like to know my audience. Thank you guys for bearing with me on there. For those of you who I haven't introduced myself to, I am Dakota Jones. I am the Business Development Manager for Kingspan Insulated Metal Panels of North America, specifically the Mid-Atlantic. I'm based in Philadelphia, and despite my title, I am actually not much of a business development manager. I'm actually relatively new to sales as well as Kingspan in general. I have 8 years of experience in architectural design. I have a master's degree in architectural building science, currently working on my AREs right now. So before you start asking me a bunch of salesy questions, just know I'm not a good salesman yet. I relate much more to you guys for the past 8 years. I've only been with Kingspan for about 9 months. But with that being said, my interest in one, envelope design, and then two, sustainability, ultimately led me to talk to you guys today, why I've been joining the Kingspan team. So before we get going, we're going to do a little bit of an outline of Kingspan for those of you guys who aren't aware of what we've been doing for the past 60 years. We're going to talk a little bit about sustainability, some of our initiatives, before we kick off with the AIA portion of the presentation. Now, the last thing I want to say before we get going is that I really encourage questions throughout the presentation. I know it's a presentation, but I do encourage conversation. A lot of people are going to have the same questions you guys have. This is kind of building science heavy. So if you guys have questions, please raise your hand. Feel free to interrupt me. I give this presentation like 3 times a week, and the monotony is honestly killing me. So I can only imagine what it's doing to you guys. So it's nice to break it up. So please ask those questions. For those of you who are less aware of what Kingspan's been up to for the past 6 years, as I mentioned, we're rather storied the history of a company. We started in 1965 behind a family-owned pub in Kingsport, Ireland, which is where we're still based today. Right now, it's still just the pub and then Kingspan, believe it or not. But since then, we've managed to grow to be a global occupation. We're now the #1 most specified insulated metal panel manufacturer on the planet. We occupy over 80 different countries right now with 212 manufacturing plants globally. We're adding one more domestic plant to this market right now. That's going to be in Illinois, providing our mineral fiber panels, specifically curating to New York's rather strict fire codes. If you guys are familiar with that, that's more of a if you know, you know kind of a situation, but know that that's happened. We're expanding every single day. We have $8.1 billion in revenue back in 2023. That number's a little outdated now, so it's 2 years old. And of course, we have 22,000 employees, which is quite a bit. We are expanding, like I said, rapidly. And the way we've been able to keep on top for so long and grow the way that we have, be the #1 IMP manufacturer in the world, is because of acquisitions, right? Companies don't get this big overnight. They tend to align themselves with other companies that share values. And that's exactly what Kingspan's been doing. About 15 years ago, we launched with an initiative that we're very proud of called Planet Passionate. This was back before like sustainability was really cool and sexy to talk about. We kind of saw the writing on the wall of the built environment, how it was going, how embodied carbon was happening, higher emissions, things like that. We realized as a manufacturer, we were a huge contributor to that effort. So what we wanted to do is make sure that we moved forward, not only in the IMP space, but also in other spaces. You can see these other companies that we've acquired, upcycling and recycling as much material as we can to give you guys the tools you need to make really interesting net zero. So even if you guys have heard of Kingspan insulated metal panels, you might not have heard of our photovoltaics division, or our hemp fiber insulation division, or our wood fiber insulation division. We also have a sister company, Tate, that does everything data center related. We have insulated walls, we have insulated roofs, we have walkable ceilings, we have insulated mechanical systems. You say it, it's been quite an endeavor. And so what we like to do is get ahead of this quite early on in the process, especially when we're introducing ourselves, to let you guys know how many hats we wear and how seriously we take the sustainability stuff. To talk a little bit more about Planet Passionate, As I mentioned, this happened about 15 years ago. And we realized that the amount of embodied carbon was increasing with the products that were being specified and used in the built environment today. So we had the unique opportunity to substantially lower that. Since you only have one opportunity at embodied carbon when you're designing a building, we had the opportunity to reduce our embodied carbon costs, and that would have a compounding effect further on down the line. And then, of course, if we could make it even higher efficiency after that effect, regarding the envelope with IMPs, that would affect operational carbon later on down the line. So it's a holistic approach of sustainability that we've surrounded ourselves with. I mentioned that writing on the wall, the thing that kind of informed Kingspan to do what we thought was the right thing all those years ago. And this was verified by organizations like the USGBC, which published this study in 2020 that basically validated their feelings. They found back in 2020, as I mentioned, that about 33% of all global energy is consumed by the built environment itself. Through its upkeep, its management, its expansion, a lot of energy. And this is projected, as you can see in the bottom right there, to increase by 50% over the next 25 years. A significant amount of energy that we're going to need. I personally feel like that number is actually a little out of date itself. I just got done with Data Center World, actually in DC about 2 weeks ago. And the amount of terawatts that these people are talking about needing just to maintain the data centers that they currently have is staggering. So I think the amount of power they need is currently underestimated. So a large increase in power is what we're seeing in the future. Additionally, they found that about 40% of all global greenhouse gas emissions directly produced by the built environment itself. It's significant. It puts us up there with one of the highest contributions of embodied carbon, or not embodied carbon, greenhouse gas emissions on or one of the top contributors as designers, as manufacturers, as the built environment itself. Then, of course, despite these numbers being so high, our energy usage being high, our greenhouse gas emissions that we're producing being so high, only about only about 3% of our current global building stock is considered efficient by companies. 97% is considered inefficient. The reason for that is because of this kind of perpetual idea that we hear in architecture law. Since I know I heard a lot back in the day, of that you got to build stuff up to code, right? Got to meet code, got to meet code. And unfortunately, this is not catering to a future in which we know it's getting a little bit warmer. The IBC tends to update its resistivity values every 3 years, and we tend not to get any more lenient. And so when we keep that mindset of meeting the minimum, eventually our building is going to become inefficient. That's why that number is so whopping. So we want to get out of that mindset and make sure we're over insulating at a very minimum to increase the efficiency of these buildings, to make sure we're building for 50, 100 years down the road. And then, of course, to kind of twist the knife even further, about 11% of all embodied carbon on the planet right now is sitting in these building materials, in these ineffective buildings that aren't even serving us as well as they should be. They're not sitting in places like, that embodied carbon isn't sitting in places like peat bogs or permafrost where it's supposed to be. It's sitting in the concrete in those buildings that are not serving us. So with only 9% of building materials actually being recycled nowadays, this is kind of a use, make, waste mentality that, again, we need to kind of move away from as an industry overall. So as I mentioned, Kingspan saw this on the wall, saw that we had opportunities to reduce embodied carbon on the products that we were making, as well as reducing our energy intensity, greenhouse gas emissions, and then, of course, making higher efficiency buildings. The reason we want to get ahead of this, as you can see in the top right, is that we need to increase our global floor area of the built environment by 2x by 2050. It's the equivalent of adding the entire city of Paris to the planet every single week for the next 25 years. It's a significant amount of carbon and energy, if not done responsibly. So it's a big challenge we face. Kingspan's been taking it on head on. And we know that a lot of people are seeing it our way as well, which is why we've been able to keep on top for so long. Back when we launched this initiative, we wanted to make sure that we were kind of setting a standard that we could measure ourselves upon. So we came up with these 4 pillars that would be kind of our North Star as far as if we got confused or wanted to decide where we were going to move as an industry. So those are energy, carbon, circularity, and water. Specifically with energy, Kingspan's big about this. We've been a net zero company for a very long time, and we want to make sure we maintain that status as we continue to grow, as we continue to acquire new companies. A lot of that is reducing the amount of carbon that's being produced and energy that's being consumed by our partners. We want to make sure we reduce that intensity by 50% by 2030. Again, we continue to expand. We keep pushing them to adopt things like photovoltaics on all their manufacturing plants, and then reducing emissions where it's easy, eliminating things like combustion engines. Right now, Kingspan is very proud to say that 90% of its fleet, including its forklifts on the manufacturing floor, the client company car I came to visit you guys all in today, it's electric vehicles all the way around, electric engines using renewable energy. So they take this stuff very seriously. Circularity is a really big important one, especially for us as a manufacturer. This is where we reduce a lot of the waste, and the way we're able to get those EPDs for you guys. If you're not familiar with that is, it's environmental product declaration. They're relatively rare, but they're going to be required if you're going to be pursuing things like LEED credits, wellness credits. And basically what it is a investigation, a life cycle analysis of the products that we manufacture to make sure they're not having harmful effects, or at least it's measured in some way. So we want to make sure that we're reducing.
So I haven't received any update from Mark yet about this protocol.
Update.
Any question or just somebody else on another call? Okay, double duty, I like it. That's fine. So back to circularity. As a manufacturer, we want to make sure we're reducing our waste as much as possible, as well as taking waste out of the landfill again where we can, make sure that we're even further lowering our embodied carbon. So we had a goal of upcycling 1 billion post-consumer plastic bottles in the first year that we set out with this initiative. We are now doing 1 billion every single year, so I'm very proud of. The reason we're able to do that, feel free to touch the samples that you got out on the table there. The reason that insulation on the inside, which is a polyisocyanurate insulation, it's formulated in-house. The reason it's gray is because it has 11% post-consumer plastic bottles actually mixed into it. That's a part of our formulation. So we're actually upcycling waste into our products, thus kind of proving it is green, be green in that sense. We also want to be a zero company to waste landfill by 2030. Since we set out with this initiative 15 years ago, we've managed to reduce our waste to landfill by 97%, something again we're very, very proud of, meaning that essentially as a global company, the amount of waste we produce from all of our manufacturing plants would be about enough to fill this room, which is pretty impressive considering how many manufacturing plants we have. To remember that 212 plus number, something we're very passionate about, hoping to kill that last 3% by 2030, but we'll see. A large part of that is a part of our take back program. At the end of this product's life cycle, the iron piece that you guys see right in front of you, the product is taken back completely recyclable if that's something you guys want to pursue. The insulation is grounded up and then put into concrete to make lightweight aggregate, essentially insulated concrete. And then the steel is recycled 100%, meaning that even at the end of its life, there's no waste. The insulation itself is R8 per inch, which means that it's airtight, it's watertight, it's thermally tight, the best on the market right now. And it really helps your guys' buildings perform while saving that embodied carbon that we're so passionate about. The final pillar that we measure ourselves on is, of course, water. This is something we're hoping to get ahead of again. Not something we hear about too much out here in the West, except maybe when like LA catches on fire, if there's a big drought. But we know that the Colorado River right now, I don't think it's made it to the ocean the past like 7 years or something like that. States are fighting over water rights. This is an issue that's going to get worse as time goes on. So Kingspan wants to do what it can to do simple things again. Harvest water, give it off to other municipalities that are experiencing drought so their firefighters don't have to worry about depleting their aquifers even more. So what we have right now is, we'll go on to our impact on the next slide. We had a goal of 100 million liters that we wanted to harvest. You can see in the bottom left there, we were able to get 34 billion in the first year. Our main manufacturing plant, it's a 300,000 square foot manufacturing plant in DeLand, Florida, about an hour north of Orlando. Surprise, surprise, it rains a ton there. So we grossly underestimated that. And we're managed to harvest that much water and again, ship it out to municipalities who actually needed it, as well as flush our own toilets and use it on our formulations and stuff like that. It's the equivalent of what 400 million American bathtubs are able to fill. So it's a significant amount of water. Additionally, just by changing some things that we've been doing, we managed in the first year, again, this is just with the products that we made, manufactured, and installed in 2020, we were able to conserve 9 billion lumens of energy. It's the equivalent of 11 million US home use over the course of the year. We're also able to conserve 164 million tons of carbon from entering the atmosphere, which is significant. It's the equivalent of what a major airline uses over 15 years. You can imagine the flack that Taylor Swift and stuff gets for her jet use, serving a lot of that carbon, so we got her back. Then, of course, upcycling those post-consumer plastic bottles. That first year, we were still kind of getting the formulation figured out. We were only able to get to 573 million, but as I mentioned, we just published our latest sustainability brochure. we're getting to 1 billion every single year, and that's because we're needing it. We're almost running out of plastic in Modesto, California, which is a good problem to have. So that's just a quick outlook of our impact. And again, we like to align ourselves with people who think like-mindedly. I was able to go onto your guys' website yesterday, find 1,000 articles. Whoever your guys' writer is fantastic. Talking about sustainability, talking about community, and it was seriously inspiring. It made my little architecture heart pitter patter. I loved it so much. So I pulled some of my best things out of there, just to kind of remind you guys that we are speaking the same language. You know, we are manufacturing. You know, get bad reps, do bad. You know, we're sales and all that stuff, but we're all working for the same goal, right? Kingspan's very big about sustainability. It's really big about resource efficiency, higher efficiency buildings, making comfortable living spaces for your guys' communities flourish. So keep that in mind as we have the conversation today. When we're talking about envelope design, I know it might not seem that important, but this is what keeps your occupants comfortable. You know, people are grumpy if they're hot and sweaty. If we keep them nice and cool and temperate, they can have better outreach. So anyway, it's great to see you guys align with this. Hopefully, if you guys have questions about sustainability, I'm the big sustainability nerd on the team, so feel free to talk to me after the fact. I'd love to talk about EPDs, LCAs, LEED certifications, all that good stuff. Now, if you're wondering why I'm coming out swinging with all this sustainability stuff, just know that I kind of have to be. We are, as I mentioned, a European-based company. We're based in Ireland, and because of that, we are subject to the 2030 Paris Accords. We're also subject to those Paris Climate Accords, as well as to maintain public tradability. We have to make sure that we're showing substantial sustainability goals that we're setting, as well as meaningful steps that we're taking to achieve those, just to maintain our public tradability. So just know that we have every incentive to continue down this path. We have no reason to go backwards in any sense, not only because we don't want to, but also it doesn't make any financial sense for us too. So just know that we've been leading the industry for quite a while, not only in innovation, but also sustainability. And even if you don't care about any of this stuff, it's just happening in the background for free. We don't greenwash any of our products. There's no premium that you're paying for this proprietary product, a quad core insulation that has the glass bubbles in. It's just how we do business. Don't even worry about it. If you guys don't care about that, or you need somebody in your corner to advocate for this kind of stuff, talk to me. I'm happy to talk to whoever about it. I get pretty passionate and heated about it, so I'm going to calm down after this. But just know that we take this stuff very seriously. With that being said, that kind of wraps up the Kingspan portion of the presentation, which means we're going to get to the AIA portion. I heard we're going to get a sign-in sheet going. Yeah. Okay. Fantastic. Does anyone have any questions about what we've talked about so far before we get into the yes, right over there?
If we're manufacturing in states.
Yeah.
In other places, are you getting around any of these rules?
Around any of these rules for what?
For recycled content. But like if our president reneges on all of these things, instead of allowing you to cheat, does it affect our ability to use the product in the first place? It's not a sustainable product.
Oh, no.
It's consistently going to be there forever.
Oh, yeah. Okay. No, I mean, we've been around for 60 years. We've been around through many different other administrations, and this is always something, like I said, it's been our North Star the entire time. I got a question last week about if we've ever nag on this or, you know, save money. We've only taken this stuff more seriously. We just hired the guy who made, is it Material Bank, the one who does all the material transparency stuff? The founder of that, the creator of that, is now our sustainability director. We have no incentive to go backwards. And like I said, some of the biggest companies that we work with, Google, Meta, Microsoft, they're crazy about this stuff. Even if we have to bend their arm a few times to remind them of their sustainability goals, they like us for that reason. And so again, we would never go back. Does that answer your question? Is that okay? Yeah, perfect. Anyone else have any questions about what we talked about before we move on? Okay. Okay, fantastic. And then folks online too, if you guys have questions, I think I can hear you guys, but probably just drop it in the chat. Again, don't feel like you need to wait till the end, no big deal, and I'll address them as we go forward. So for everyone attending today, expect an email later this week from AC Daily. You'll recognize it from its little Apple logo. That's where you guys will get your certification for this. You'll be getting one continuing education as well as an HSW credit. So just keep an eye out for that. If you don't get it in the next week, email me, tell me that you're upset, and I'll try and figure it out for you. So no big deal. If I do my job correctly today, we're going to walk out of this room knowing these 4 key objectives. One is how do we design an effective building envelope? We're going to be talking about the challenges of multi-component backup wall systems. This is your wall sandwich that you'll learn in Black Spectacles, neighbor books, stuff like that. We're going to be talking about how we can get higher performance out of a single component backup wall system. Spoilers, it's IMPs. And then we're going to be talking about the design flexibility of IMPs, insulated metal panels. That's an acronym that we're going to be using quite a bit throughout this presentation. So kicking off with learning objective number 1, how do we design an effective building envelope? I apologize in advance if this seems a little 101 to you guys. It's just to set the foundation for what we're going to talk about. So how do we design an effective building envelope? To kick things off, who has heard of Dr. Joseph Stiebert by chance? The famous building scientist? 2 people, that's more than most. Love it. So for those of you who aren't aware of this gentleman, he is like I said, a building scientist. He's obviously very Canadian, if you can't tell by his name. But he's responsible for a lot of the more stringent codes, specifically in like California and stuff, regarding energy efficiency. He's referenced quite a bit throughout this presentation. He's kind of a god to a building scientist nerd like me. So just know that he's kind of what we're referencing throughout, but his research is solid. So throughout his paper, The Perfect Wall, which identifies the Rainscreen as the kind of perfect wall in any commercial application, he wants to emphasize that as we move toward an industry that is a little bit more progressive on sustainability as well as energy efficiency, these are the things that you want to kind of pursue in order to get those higher efficiency numbers. The first one is super insulation. And that kind of goes back to that initial 97% inefficient number that we were talking about, right? We're not building buildings for 3 years when the IBC updates. We're building buildings for 50 years, 100 years down the road. This is the mindset that we need to kind of keep in mind. Now, if we go above and beyond the minimum required insulation value, we are protecting ourselves not only for the next few years, but for the future. So this is kind of a must if we're talking about higher efficiency. It's our main thermal block from keeping energy from coming in and going out where we don't want it. Then, of course, we don't want to go through all the trouble of making an R126 wall and then have a bunch of cracks and seams with really cruddy windows specified and poorly detailed. That's going to lead to air leakage. So it's kind of a holistic approach. You want to make sure you're reducing air infiltration as much as possible. Because again, as long as air can get in, energy can get in. Cool, warm, all that stuff. And that's unintended infiltration. That's not what we want. That can lead to unsafe environments as well as lack of efficiencies. And then finally, we don't want to make an airtight, thermally tight square, opaque little box, and then ram a bunch of structural members in and out of it willy-nilly. That's thermal bridging. We don't want that. Again, that allows energy to go in through there like a sieve, and we want to make sure we reduce that. So again, holistic approach, looking at the envelope, not just as a wall, but as windows, as openings, as penetrations, all those things. It's a holistic thing. As you employ these 4 strategies that Dr. Joseph Stiebert talks about, you should have something that should be resembling a wall. This will at least keep the wind off your neck, keep your building standing for a long time. If you have a strategy to control the rain, control the air, control the vapor, and of course, control the thermal loads that are going to be put on the outside of your building, you should be good. And then you can start employing those other strategies we just talked about later on. Make sure that you are going above and beyond and actually making a building that's going to be efficient throughout the life of the building. He has a rather cheeky quote that says, if you can't keep the rain out, don't waste your time with the air. If you can't keep the air out, don't waste your time with the vapor. Again, holistic approach. This is kind of a fun way of saying you have to look at this from a macro scale as well as a micro scale, right? If you have a big hole in your roof that's letting in the rain, you don't need to worry about wasting your time with an air barrier. It's just going to come in through the hole. But additionally, if we have those cruddy windows that we talked about with poorly specified, poorly detailed joints, and there's a lot of cracks and seams, and we have air leakage, don't worry about a vapor layer. It's just going to come in through those cracks and seams. So again, holistic, everything's tight together, making sure that we're doing and detailing everything as well as we can. Another cheeky quote he has that we don't reference is he says, the worst thing about stupidity is that it normally shows up to the party late. So we just don't want to miss silly things, right? A small detail that's going to lead to missing a backer rod or something, and then all of a sudden we have a leak 5 years down the line. So again, holistic, being smart. I know you guys get that. We're all architects, we get it. The reason we want to be holistic, the reason we want to be airtight, hygrothermal loads. This is a real word, I promise. It is the intrinsic movement of heat, air, and moisture through your envelope. If you guys aren't familiar with this, don't watch too many building science videos. Know that if you have like an inch cut in your air barrier, vapor barrier, cups of water can be sitting in your wall cavity over time. It's a significant amount of vapor that can get through there, and that's because of hydrothermal loads. This is vapor that's floating around in the air. As soon as it meets a cold surface in your wall, it condensates, and if it has nowhere else to go, it sits. That leads to mold, that leads to mildew, that leads to unsafe environments, okay? So, hydrothermal loads, keep that in mind, new word for you guys to learn hopefully today. How we've done walls in the past are kind of outlined here. We'll start at the top and work our way down, starting with mass storage walls, right? This is kind of a basic wall that we can come across. Use local materials that are lying around, rubble, stone, masonry, concrete, stuff like that. Semi-porous materials, right? They did a good job of keeping the wind off our necks, for sure. But they also did a really good job of, as you can imagine, absorbing, storing, and then redistributing not only heat, because we think of these as thermal masses, but also water and vapor, right? You can imagine this getting wet, and then as it dries, it evaporates on both sides of the wall, kind of indistinguishable what's outside and what's inside. This is how we get that grandma's basement smell, and it's not a holistic strategy because it's not protecting you against vapor, it's not protecting against water infiltration, just protecting against basically wind. So what we've moved toward is more of a barrier system, which is kind of a belt and suspender approach, right? This is a impervious surface. This is something that's going to be really, really strict as far as like structural glazing, steel, stuff like that, impermeable. And what that does is it blocks 100% of that water, air, all that stuff from ever getting into the envelope. But it is subject to wind-driven damage, unfortunately. Like I mentioned, if we don't catch that crack, we don't catch that little slit in that barrier, this can lead to problems over time. So it's again, a really good strategy. It blocks 100% of that stuff from getting in. But what we want to do is kind of protect it. And that's where we've come up with the drain system assembly. And you guys might recognize this as a Rainscreen. This is the bottom one. What we did is we took the benefits of the barrier wall, which is essentially what our backup wall is going to be. It's where all the magic happens, our thermal protection, our air protection, all that stuff. And it put it behind a nice, pretty shield that we call a Rainscreen with an air gap in between the two. That Rainscreen can be virtually whatever we want. We could do brick, we could do cladding, we could do ACM. You guys know what a facade looks like, right? As long as we have that air gap behind there for any water that gets through to condensate and then go through a weak hole down the assembly, we're good. And what we have is a system that's protected, it can breathe, kind of employing the two strategies that we talked about from the first, that we kind of learned from both of those and moved on to the drained wall assembly, thus the Rainscreen. And as you can imagine, this is what Dr. Joseph Stieberg identified as the perfect wall for commercial applications. This is an 80-year wall, 100-year wall, if done correctly. As long as you have that air gap, you're pretty much good to go. That exterior Rainscreen, as we talked about, can be virtually whatever material you want. As long as that air gap is present, you're good. As long as you're meeting fire codes, of course. But the backup wall is where the magic happens. And this is where our strategies are kind of employed, right? So you can see we have our thermal control. We have some way to protect those thermal loads as well as air, vapor, water control. So our weather resistant barriers, things like that. We'll talk about how this wall sandwich goes together in just a few slides. But the only other thing I want you guys to remember is to protect that air vapor control there, right? If that surface gets cold, that's when condensation happens. And as you can imagine, if that condensation collects on this side, if these two were to reverse, that thermal control were to be inboard, that air barrier to be on outboard, it was exposed to the winter air and it got cold, condensation would occur on the outside. And that's not a big deal from the exterior. But you can imagine from the interior, as we continue to breathe, cook, stuff like that, it's going to collect on that surface and it's not going to have anywhere to go. And that's where you get the issues of mold, mildew, and all that stuff. So make sure it's not only protected via that Rainscreen, but also thermally, right? We want to keep it consistent temperature. Well, always remember, keep that air barrier on the winter warm side of the insulation. Very important. Now, Rainscreens are great, right? They have a lot of pros, they have a lot of cons. First pro is that they're really effective at moisture management, right? They're very versatile in their aesthetics. As I mentioned, that Rainscreen can be virtually whatever you want to match whatever your client's needs are, whatever you want to achieve. They're also very common nowadays. People know how to detail them, people know how to make them. But they can be very complex, right? This is a wall sandwich that we're suspending another sandwich from, essentially. So what we're relying on is really good detailing, and then of course, really good to near perfect execution from multiple trades needing to work collaboratively in order to make this thing actually happen. That leads to higher maintenance costs. As you can imagine, there's not one team who could do your entire wall, do the sheet, the Zekers, the installation, do all that stuff. It's multiple teams doing multiple trips around the building. That's longer construction schedules, and that's a little bit more money to actually get everything done and done correctly. This leads also to energy efficiency limitations. You can imagine all those cracks and seams in between the boards and between the insulation, those Z-girts holding onto the insulation outboard, those are thermal bridging, right? So there's elements that could be fixed upon by kind of reducing some of this complexity because of those thermal bridging, because of how many people are needed in order to achieve this. So this brings us into learning objective 2, where we get to dive a little bit deeper into the challenges of multi-component backup wall assemblies. This is our wall sandwich. For the next few slides, we're going to talk about kind of the traditional approach that you guys would need to take, depending on your climate zone, that you would actually need to employ to create a wall. Starting off with ASHRAE 90.1, you want to kind of define the boundaries of what your wall needs to do in order to perform well. If you guys are not familiar with this map, first of all, NVU. Second of all, definitely Google it. It's very, very important. It's going to tell you what climate zone you're in, which is going to determine your R value, your U value alternatives, as well as if you are going to be in a moist environment, a dry environment. It's a lot to learn here. This is going to build kind of the barrier, the boundaries of what your wall needs to do in order to perform well in the area that your building is going to be. So step 1, define the parameters. And then step 2 is figuring out specifications, figuring out what products you're going to employ to actually combat all of these loads that are going to be put on top of your guys' buildings. Now, this is where stuff gets complicated. And believe me, I'm not the air barrier guy. I'm not the weather resistant barrier guy, but there's a lot of steps to be taken here. First of all, some of these products are double duty, meaning that they can either be retarders, they can be barriers, they can work as an air barrier and a water barrier. Some don't, some others do. They can be reps, they can be fluids, they can be sheathing. There's so many things to consider. And then to make matters even worse, of course, they're broken down into classifications of permeability. Who knows what a perm is? Anyone? 2 people. Love it. That's fantastic. So hopefully you guys learned something today. A perm is a drop of water that can make it through a square foot of a medium at 0.5 pressure differential over about an hour. So you can imagine if I was holding up a piece of paper, poured my tea on there, a lot of water would get through that. That'd be a permeability rating of however many drops actually made it through. You can imagine it'd be like 40. It'd be a lot. With that being said, building materials are classified by class 1, 2, and 3. Anything class 1 is considered impermeable. That is 0 to 0.1, meaning that at most 0.1 drops of water is actually getting through that medium. Classification 2 is a little vapor open, right? It's 0.1 to 1. A drop of water can get through that. Classification 3 is 1 to 10. 10 drops of water, maximum. Anything past that is considered vapor open, right? It's permeable. It can still defend a little bit, but allows water to get in and out of that system as needed. And you guys probably know that you guys have a lot of multifamily housing, or maybe you don't. These can get up to permeability rating like 40. They can be very, very vapor open building papers out there. Other manufacturers, as I mentioned, will come in here and explain this way more to you about how your wall needs to breathe, how water needs to get in and out and stuff. You know, I'm the INP guy. We don't believe that water should ever be in your wall, but I digress. So that's kind of step 2, is figuring out what your specifications are, how you're going to employ the strategies that we talked about to make sure that you have a wall that's going to stand and last the test of time. And then let's say you select your insulation, everything's going to be held together correctly. And so we get the detailing, right? Or maybe we have an intern do our detailing for us. We have to figure out how we're going to get this sandwich connected, how we're going to keep it tight, how everything is going to work well. And this is where one of the flaws of multi-component systems come to kind of show its ugly face, which is a lot of penetrations, a lot of potentials for thermal bridging, as well as capillary action to occur with, fasteners to go through that insulation back into the structure itself. So we want to make sure that we execute this perfectly, detail it correctly, no negative laps on our windows, things like that we run into when leaks happen 5 years down the road. If we do everything perfectly, if we detail everything, like I said, as best as we can, all the I's are dotted, all the T's are crossed. You guys hire the perfect GC who hires the perfect subcontractor. Guy never misses a step, right? GC comes by and verifies that every single penetration is like completely sealed, kissed on the head, tucked in at night. Everything's beautiful, right? Despite my joke, unfortunately, that never happens. And so even if it did, however, you would end up with a system like this. And if anyone can notice, it's penetrated thousands and thousands and thousands of times, which is an inefficiency. It's a very blatant inefficiency, right? These are all potential fail points because, again, GCs do miss studs. For Subcontractors do miss studs, right? And even if they go in and realize, and then they just scoot it over a little bit to the left and go in, they don't realize there's a big 1-inch hole behind there. So maybe they're sealing the front, they're not sealing the back. So this is an imperfect system, again, primarily due to its complexity and how many cooks in the kitchen are required in order to do this correctly. So last thing I'll say about this is with the amount of trades that are actually required. So you guys can imagine with this ACM application up top, you got the sheathing, you got air barrier, you got insulation, Z-girds, hat channels, all this stuff supporting your exterior rain screen. It's going to take about 4 to 5 trades to get that done. It's 4 to 5 trips around the building, a lot of hands working together, a lot of details that need to be executed perfectly. And then what happens if 2 years, 3 years down the road, there is a leak, right? All of a sudden you call up the ACM guy, the ACM guy's like, as a Z-gird guy. Z-gird guy's like, as the insulation guy, insulation guy's like, it's the plumber for some reason. And then everyone ultimately blames you guys, right? You're the architects. Maybe you missed a detail. Maybe an email wasn't sent. You end up with a situation like this, right? It's a who's who of who screwed up. Nobody knows. And then litigation happens. Ultimately with you guys, unfortunately, at the state pretty frequently. So what we have is a system that is one, inefficient. It's complex, takes a lot of time. And then of course, if something does go wrong, you have like 30 throats you need to choke to figure out who actually did something wrong. With IMPs, this is where we're going to talk about IMPs. I know we've been burying the lead for quite a while. It's one component system, right? This is a insulated metal panel. It's a barrier wall because it's 22 to 26 gauge steel on either side of highly dense insulation. It mounts directly on the studs, which means there's basically no ambiguity of who screwed up if there is a problem. Kingspan. Right? So essentially you have ease of construction, one throat to choke, and then of course, the one thing I forgot to mention is this goes up about 30 to 40% quicker than multi-component systems, meaning that you can get enclosed quicker and your interiors team can get going even sooner, meaning construction schedule savings is key. So you guys can play with the samples that I brought with you today, as well as poke through some of the brochures. I know some of you are tired of me making awkward eye contact with you. Don't worry, you guys aren't hurting my feelings. Feel free to poke through. But these things snap together just like Legos, right? They're really easy to install. As I mentioned, they go right on the studs in every single climate zone, are 8 per inch. And of course, they are the kind of saving grace for a multi-component backup wall system, right? Because how do we make it a better backup wall system? So we make it less complex. We take out all the steps. We make sure that we can perform with just one component. So let's talk about how we do that. It's a bold claim to go in here and talk about how complex walls are and then say, I have a product that can solve it all, right? Well, let's look at the kind of chemistry of IMPs. What we have here is the most complex point. As you can imagine, this is just continuous insulation throughout the steel in between these 2 sandwich panels. But at the joint is where we could potentially run into issue. So let's talk about it, right? This is going to be a dual jointed system, dual gasketed. Sorry for people online. I'm using some visual aids, but just try and follow along. I apologize. What we're looking at is the joint detail on the left right there. What we have is double gasketed. The reason for that is because this is our air barrier, our water barrier, our vapor barrier, and our thermal barrier, all in one. The reason it's double gasketed is because of the pressure equalization that happens in that panel as pressure is pushing from the outside of the building via wind, pressure pushing inside to the outside of the building via, HVAC system, stuff like that. So what we have is equalization within that joint, allows a little bit of flexibility, ultimately keeps air tight. Additionally, we can look that our fasteners are covered by the IMP that is going to go on top of that fastener, which means we are not exposed, which thus greatly reduces any issues of like water-driven rain, wind-driven rain, things like that. Obviously, it's thermally protected. We're talking about our 8 per inch. These panels can get up to 8 inches. They can go down as low as 2. And then, of course, what did I miss? Vapor, air, water, thermal. No, that's everything. Mounts directly onto studs, but you can imagine, even if water does get through that initial joint, it would have to travel, defy gravity, go up and around that gasket, up there, up and around that gasket, just to reach back to the studs, which is where our air sealant is. What we use as an air sealant that we mount, essentially glue the panels onto the structure with, is called non-skinning butyl. It's a really interesting product that is a lot like silicone, but it sets itself apart because it never gets dry. You can imagine with silicone around your bathtub and stuff, when it does get dry, it peels off, it flakes off, it's not good, right? With this stuff, it stays wet throughout the entirety of the building, which means that even if that assembly moves a little bit, it still keeps that nice tight air sealing. We have buildings that we've decommissioned after 80 years and this stuff is still wet. It's a really interesting product. So we'll talk more about that during the install video. There's an install video in case you guys aren't getting how this stuff is going to go. I know it's a little confusing, but we'll We'll get to that in just a sec. We can see the thermal performance of IMPs, even on a Rainscreen application, are much more consistent compared to a multi-component system. And that's because of that thermal bridging we talked about, specifically with the secrets. And I know you guys probably go to trade shows. There are a lot of thermally broken secrets out there, a little bit more expensive for sure. But what you have is way deeper thermal penetration there on the left in that multi-component system, whereas with IMPs, even at the most complex joint point of the assembly, which would be at the joint, you have much more consistent thermal performance, less deep thermal penetration, and a more consistent overall envelope high efficiency design. To talk a little bit more about the insulation itself, as I mentioned, this is a polyisocyanurate. Obviously, that is a very long word that I never want to say. So we shortened it to PIR. PIR is polyisocyanurate, and it's very common on the market today. We formulated our own. It's proprietary. AIA requires us to call it ultra high performance PIR. So just know that I'm talking about that while I'm talking about ultra high performance. But I'm in AIA mode, so hopefully you guys are not AIA, please. But anyway, when we're talking about ultra high performance stuff, that's the R8 number that I keep spewing out to you guys. That's the distinctly, not orange, my goodness, distinctly gray color. It's the recycled plastic. It's all that good stuff. Standard PIR acts very similarly. It's about 7.2 resistivity, and both do very well in fire performance. What we've learned from using polyurethane, which was kind of what we did back in the day, if you see this stuff, it's dark yellow, steer clear of it. The reason that we moved away from that is what we learned, which is it's very poor fire performance. Polyurethane, back in the day when it would catch fire, it would smoke tremendously. It would drip, it would bubble. It just wasn't safe to be around. And it only had a resistivity value of 5.2, so it wasn't great. PIR chars a little bit, virtually no smoke when it's on fire, performs much, much better. And again, that resistivity value is killer. So that's great, but that kind of distinguishes the three. But also know, depending on what your guys' fire requirements are specifically for your guys' application, again, this is big in New York, that these panels can be swapped out their insulation with mineral fiber. That can get you up to a 3-hour wall if you really need it. You can see on the bottom there, you are going to take a big hit to your resistivity. Mineral fiber, it's like rock wool, essentially. 3.6 per inch, that's kind of like maxing out there. So you're going to need a lot more of it, but again, you get that stellar fire performance. Polyurethane, polyiso standard, it's going to be a yellow color, not quite as yellow as the polyurethane, which again, if you see, just steer clear. And then, of course, our proprietary product on the right there, highest on the market. Both are great at fire performance. This is the install video. Hopefully this doesn't chug too hard. But we can see that at the point where two IMPs meet butt to butt, we are going to have this condition, which means there's going to be some coordination structural. We need a double stud with a mending plate over the top. At the slab, we're going to need our starting extruded J channel with its double gasketed for the IMP to sit in. We have two lines of that air sealant we talked about, the non-skinny butyl. That goes over the back gasket as well. That's called the marriage bead. We'll talk about that in just a bit. That IMP is essentially glued onto that and then fastened with this gasketed clip right back to the structure. That is that marriage bead again that I talked about. That is to complete the air sealant and essentially keep any water or air from entering in the system laterally. And that next IMP goes on top of that and is fastened at the top, virtually the same way. So everything left of that stud system, it's airtight, it's watertight, thermally tight, it's good to go. But that next IMP is going to go just to the right in the exact same way. You can see the non-skinning butyl fastener is covered by the IMP over and over in the top. And then, of course, what is not shown in the video, to my utter dismay, is at the very minimum, we would recommend that you guys put some mineral fiber behind this pressure-fitted gasket, which is mainly there just for looks, because it's obviously a thermal short in the system. Alternatively, because I'm the higher efficiency guy, I would recommend doing something like the detail shown in the bottom right, which is a block spline detail. Essentially what this is, it's like an inch thinner IMP that goes onto that double stud system before your IMPs go on, and you get much more consistent thermal performance. If you guys get used to that, we'll talk about it after. Does anyone have questions about the install video before we move on? No? Okay.
I have a question.
Hey, what do you got?
You're showing this installation with metal studs. Have you guys looked at it with wood studs as far as the quote unquote shrinkage as the building dries out?
Yep. So that it's definitely possible. We do it quite often. There's some additional steps we need to take in order to make sure that that wall that we're mounting to is essentially dead flat. That can be achieved with like hat channels, things like that, but we're not unfamiliar with that. But we can also mount to existing building surfaces as well, including brick, CMU. We also have done a few projects with like CLT and things like that. So as far as specific shrinkage and stuff, that hasn't been an issue yet. So it's just some more steps we have to take. Does that answer your question?
Yes.
I was going to assume yes. That's perfect. Okay. Anyone else? Any other questions?
Do they require in addition to?
Yeah, for those of you who maybe couldn't hear that, he was asking about whether or not these panels provide shear. It's a great question. One thing I will say about that is that these are set apart kind of from a SIP panel, structural insulated panel. These are not that in any way. They don't provide shear value. They don't provide structural value in any way, right? These are just meant to be your envelope. You do want that shear value, stuff like that. That's going to be shown in your structure. We'll talk about how we do a Rainscreen after the fact, but even in that application where we can integrate the hat channel into our panel, that facade load is then put right back to the structure. It's not supported by the IMP at all. So does that answer your question? And you, sir?
And from this diagram, we're just putting drywall on the inside.
Yes, sir.
Yeah, that's it.
Absolutely.
There's no sheeting on the outside.
No, no sheeting on the outside. If we were getting really complex with our geometry, that's actually a good question. If we were getting really complex with our geometry, we were doing like a running bond where the joints were going to stack up on top of an IMP, does that make sense? We would want to include an additional air barrier. And the reason for that is because, again, it's just an obvious place for water to pool. Kind of a belt suspender approach, but we want to make sure that we're dealing with that. You open that?
Their maximum length for the panels.
4 feet. Oh, is that the question? Yeah. So these panels, we will talk about dimensions a little bit later on. These panels can go up to 50 feet, and they can be 4 feet wide. Our architectural panels, which are the ones that you guys have over there, those can be modified width-wise up to 1/8 of an inch, depending on what your guys' requirements are. If you're trying to line up with a soffit or a window head or something like that, just know that that can be modifiable. These more commercial panels, they're going to come in 2 feet increments, up to 4 feet. Well, I guess foot increments starting at 2 feet, but then they're going to be significantly cheaper. But you can modify them a little less. So, good question. This brings us into the first part of our last objective for today, which is IMP design flexibility. This is where we get to talk more about rain screens. What we have shown on the screen here is what we call a carrier panel. And this is what I was talking about with that integrated hat channel in there, what we call a carrier rail. What we can do is take advantage of that hidden fastener and suspend essentially a hat channel from the face of that IMP that can support another hat channel. And then if you can see there, that little blue line, we have our air gap, which means that we have a backup wall, we have an air gap, and then we have an exterior screen system, thus making our rain screen perfect wall one component system. So it eliminates a lot of the guesswork out of that whole system. With that being said, I already talked about this, but the facade load, as you can see through the fasteners, is going to be carried back to the structure, not to the IMP. So thank you for already answering that question. We'll go through a few examples of kind of what we're seeing in the market growing as far as exterior facade finishes. This is kind of curated to your guys' territory, the Mid-Atlantic, what we're seeing growing, especially with like higher education and stuff. Starting off with plate, obviously we make insulated metal panels, and so we're big on metal facades. With that being said, for those of you who are not familiar with what plate is, it's a great way of getting metal on a building because of its thicker substrate. The reason you want a thicker substrate is because it kind of fights the phenomenon known as oil canning. What this is that as metal essentially heats up or cools down too much, it gets kind of wavy, really ugly on facade loads. You might have seen this for some applications, especially on towers. Plate does a really good job of fighting against that because of its thicker substrate, it's stronger. IMPs also do a phenomenal job with this, again, because it adheres to that insulation on the back there. And so it keeps much more rigid for longer spans. Obviously, if you wanted to do a 20-foot panel that's dead flat in the middle of Arizona and paint it black, we would have a conversation. But plate is a great way of getting metal on a building, same as IMPs. ACM, NCM, something you guys should all be familiar with. It is on every car dealership you've ever driven by in your entire life. It is aluminum composite material or metal composite material. What this is, it's a much thinner sandwich panel with a core, make sure if you do use this, verify whether or not you need a fire rated core, specifically for how tall your assembly is, stuff like that. I won't get into it. But another great way of getting metal onto a building, especially if you want to get really complex with its geometry. The one thing that ACM, MCM has over IMPs is that it can do, star shapes if you really want to, because it's not relying on any kind of a joint system to integrate. It's just being suspended. So with that being said, this is normally where I start losing folks if it's a hot room or we're just getting tired of we just ate, things like that. So what I have up here is a little bit of a guessing game. One of these is an IMP application that's exposed. The other one is a Rainscreen using ACM. I'm going to have you guys guess which is which. I won't have you say it out loud. I don't want you guys to embarrass yourself. I'll give you 3 seconds while I steal a cup of coffee. Got 3, 2. Okay, who got it right? 3 people. Wow. Okay, cool. Interesting. So yeah, IMPs are on the left there. You can see we have that nice bond there. This is the David Beckham, my soccer stadium in Miami. We still can do cool colors just like ACM. We can still align with full soffits and edges, things like that. ACM obviously does that in abundance, but in a relatively simple geometry, IMPs can achieve what ACM can do as well. We order the coil for your guys' project, which means that it's coded by a small company you guys might have heard of, Sherwin-Williams. Yeah, okay. So if you can think of the color, they can make it essentially. Not a big deal. With that being said, we still have that pink coil sitting on the floor today. And sometimes we'll put it on the backside of panels because it gets covered up by chipboard and it always gives the GC a heart attack. But yeah, it's fine. Single skin, another way of getting metal onto a building and kind of our last flavor of metal that we'll talk about today. Single skin is great if you want that kind of industrial look. It's corrugated. You can perforate it. You can twist it. You can bend it. It's a good time to mention IMPs can also bend up to a foot radius, which is pretty impressive. That being said, though, single skin is great because you can perforate. You can do a really cool kind of high design Rainscreen on that application. So we'll do another quick little comparison game. Which one's the IMP and which one's the Rainscreen? I'll give you guys another 3 seconds to decide. Okay, we got it. Switched it up on you. Nobody got it, or everyone's shy. That's fine. That's fine. IMPs are on the right this time. IMPs can't be corrugated. I know, controversial, crazy, right? The only way you could actually tell this is a corrugated IMP would be, and you can't even see it on this big screen. People online might be able to see a little better. There's a bit of a seam at the top of the window jamb, and then like 3 feet down is another seam where the actual joint connection is occurring. But that's a 3-inch panel mounted directly on the studs in Maryland. And it's performing like that. It's doing great. So you can still get the same look. Again, that nice continuous integrated system going on, for about 50% of the install time, which is great. Thin brick, another great one that we are seeing growing in your guys' market in particular. Doing 2 projects with CGF right now at Johns Hopkins, and it seems like this is going to be kind of standard spec. You guys are familiar with thin brick, or I think like Glengarry's True Brick system. Essentially, what it is, it's a that you can attach onto a Rainscreen and then snap bricks in, and then essentially just kind of pipette mortar around it. So you don't even need a mason, and it looks like brick. It is brick, and it's also a 1/6 the size of brick, which means a 1/6 the amount of carbon, which I'm always a big fan of. But anyway, you see this growing in the market today, and it can be suspended from a carrier panel system. Of course, extrusions. Everyone has extrusions if they have metal panels. Hopefully, just know again, we also are coating your guys' stuff. So we have that on hand. If you do need a custom knife or something like that, we can have that discussion. But if you need to communicate an edge, celebrate an opening, whatever your design intent is, just know that we can also do that for you. This is also a good time to mention that IMPs can also be mitered on the inside and then bent 90 degrees. If you do want a seamless edge, that right photo communicates that a little better. Again, I'm sorry for the people on the projector screen, but there essentially is no edge because that skin is continuous on the outside. Because we essentially just edge that IMP. A few case studies. This is the Code Building in Charlottesville, Virginia. This is a 2030 challenge project as well as a LEED Platinum building. Is anyone familiar with this building? Kind of in your guys' neck of the woods. Very interesting building. I had the opportunity to visit here about 3 weeks ago. Sent some emails. It was so warm. It was so quiet. It was very high performing. Also, 95% of it is carrier panel on the back there, supporting that thin brick facade. Don't ask me how they got the pins on there. I have no idea, but I would love to see a wall section. It's a very cool looking building. Going into something a little bit more industrial, this is in Quebec. You guys can imagine these panels are much thicker, as well as larger. You can see that this kind of celebrates the height of what you can achieve with IMPs. These are about, I would guess, like 48 feet, something like that. What this was a distribution center for a shoe manufacturer. And what it was a corner lot condition where the customers came in from one edge. I'm assuming you guys can decide which facade the customers got. And then the employee lot was just to the right of it. So the employees, of course, get the drab slate color, and then the customers, of course, get that really fun rain screen. So what it is they just went exposed IMPs all the way down, got to that curtain wall system, switched out the joint, and then went to a carrier system, which has that suspended rain screen on the outside with the perforated single skin, so that, you know, the IMPs painted on the black, really slick, cool looking install. This is the Cornell Arts Complex in Joplin, Missouri. Again, kind of showing the cool geometry that you can achieve with IMPs. Again, these can be modified up to 1/8 of an inch. You can see that they line up with windows, they line up with soffits, they can kind of communicate height as they go up. And they can also be swapped out as you go left to right into a rain screen application, meaning that you can get communicate a little bit more design with that IMP kind of through your selection. So the only thing I like to mention with this one in particular is the architect wanted to celebrate the mining heritage of the town. So I always thought was funny because I personally wouldn't have gone with pearlescent white, but who knows? Maybe they were mining talc. I'll let you guys decide how successful he was with that one. Gilbert Place at Virginia Tech, another one kind of in your guys' neck of the woods, or maybe not. Again, I'm from Idaho, so I don't know how far away stuff is, but Brian, you'll tell me after the fact. Gilbert Place at Virginia Tech, very interesting building. Again, mostly carrier panel as the backup wall to this rain screen. And as you can see, the building was massive, and they wanted to do better at kind of breaking up the massing as it went up to make it kind of not seem like a giant spaceship had essentially landed on campus. So you have more durable materials on the bottom via that thin brick, in case weed eaters or whatever need to come by, a car crashes into it, something like that. You have that durability on that rain screen, and then get more fragile as you go up. You got things like maybe Nichihad, exposed ECM, and then of course just, you know, you run in the mill exposed IMP up there on the panel. So you can switch materials as you go up. Obviously, as long as you have that consistent substrate on the back, you know, your wish is there, man. You can do whatever you need to do. This brings us into our final learning objective of the day. I appreciate you guys sticking with me for so long. No more games, I promise. So this is amendments and building regulations, quick code talk before we wrap things up. If you guys are going to be considering using IMPs, just know that it is a plastic insulation, which means that you will be subject to NFPA 285. It is a pass-fail fire test. Who's familiar with this test? Anyone? Oh, you're more people. That's fantastic. Cool. So I'll let them get more deep into it with you guys if you want to have a chat after the fact. I'm just going to go over it briefly. Essentially what it is, it's a fire test to make sure that your entire assembly performs, meaning that it's not just the IMPs, unless it is you want just the IMPs, you would have to suspend your rain screen, whatever it ends up being, to make sure that it performs well. It's a 30-minute fire test. It's also very badass to see in person. If you get the opportunity, I highly recommend doing. 30 minutes, pass, fail. They measure fire smoke, fire spread, all that good stuff, just to make sure that everything is safe. Just know IMPs are subject to this all the time. If you're using more conventional construction products, a lot of this stuff has already been done, so no need to worry about it. Of course, with that being said, IMPs, our products, most IMPs on the market right now are FM approved. It's the highest industry standard you can get from an insurance standpoint, meaning that they perform very well in fire scenarios, though we just can't get you that hour rating unless it's mounted to a UL rated assembly, doubling up on your chip, something like that. That being said, quick example of a fire experience with this. This is in Belgium at a BMW car dealership. There's a battery fire, unfortunately. But what is not shown is the other side of that wall, which is a bunch of happy German workers doing whatever happy German workers do. I imagine a lot of dancing, probably drinking, maybe working, who knows. And this brings us into our final point about chapters of code that you guys are going to need to reference if you guys are, again, choosing IMPs. Depending on what your application is, there's kind of two flavors you can approach this. Chapter 14 would make sense. Relates to MCM, you know, metal facades, all that stuff. Just know it's a little bit more restrictive on things like square footage limitations, height limitations. And just know that you have chapter 26 in your back pocket as well. Specifically deals with IMPs, way less restrictive on square footage limitations, separation limits, height limitations, all that other stuff. So if you are getting pushback or whatever, just know that you have that in the back pocket. So kind of a trick of the trade. That being said, we already talked kind of about the speed of assembly. That's where you guys are going to save a lot of the money, of course, is making it up in the construction schedule. You guys are getting pushback from GCs. Just reassure them you're going to make up a lot of time for other people to mess up. It's going to be great, I promise, right? That being said, the price of these materials, we sell directly to installers. And so our price right now for something more commercial, like what's shown on your guys' table over here, less complex, a little bit, we'll say uglier. This is stuff you would see on like IKEA or Walmart or something like that. It's going to be like 10 to 12 bucks a square foot for the material alone. Install is going to be a different price, but we have installers we can provide to you guys. Something more bespoke like that. You want a custom color. You want that nice manufactured joint in there on your guys' table. You want the seamless edges. You want to do bends, something like that. That could easily crawl up to like 36, 40 bucks a square foot for material. And then install, of course, is going to be a little bit more on top of that. But again, we have stellar installers we're willing to recommend with you guys. And just know with that price, that especially if it's a bespoke product to you guys, we are coming out and verifying measurements in the field, stuff like that. And this is going to be shipped ready to install again, like I said, a Legos. Your corners are going to be perfectly measured. It's going to snap together in 50% of the time. So just know that moving forward. With that being said, we know this is relatively new technology, especially out here to the west. If you guys know it, great. If not, just know that a good majority of those 22,000 employees I was talking about were all nerds with engineering degrees who are foaming at the mouth to help you guys with your details. If you guys have complex soffit details or want to have a question answered, send me a napkin sketch. Napkin? Is that weird? Send me a napkin sketch, something on the back of a piece of paper or whatever. We'll get it figured out. I can get you guys in contact with whoever you need to contact. I am also kind of your liaison between the entire Kingspan team. We talked about all the other subsidiaries, companies we own, stuff like that. I didn't even mention our competitor with Calwell. We also have high performance semi-transparent panels. If you guys are interested in any of that, want additional lunch and learns, reach out to me and I can make sure to set that up as well as get you guys his projects, questions answered, stuff like that. So we're here to support as well as full outreach staff. With that being said, any questions before we wrap stuff up? I always like to leave off with details. We also have Revit families if you guys use that, but questions? Oh, one online. Can we have these slides? I would love to send you a PDF copy of the slides. That is completely fine, yes. I'll send that to, can I send that to you? Yeah, no, not an issue at all. Anyone else online or in person? Yeah. Okay, feel free to grab some more food. Thank you, everybody. I'm going to be here for another like 10 minutes if you want to talk about projects. Otherwise, thank you so much.